Today's problem is next element with greater frequency, difficulty medium. Accuracy is very high. It could be very high because, well, I don't know. It could. I guess you don't know in advance what the problem of the day is going to be. But this is almost exactly like the problem of the day from yesterday, which was to find the next greatest element in a circular array. The differences here are minimal. I mean, with the circular array, you could wrap around and look for a greater frequency. So for the last element, for example, you could wrap around to the beginning and look for a greater element. That isn't the case here. For example, in this case, next element with greater frequency, the last number, there's never going to be a next element with greater frequency. So given an array of integers, for each element, find the closest element to its right that has a higher frequency than the current element. Higher frequency meaning that it occurs more frequently in the array. If no such element exists, return -1. All right. This one we'll use as an example when we look at the code. But this one, well, this one's pretty simple. We've got 5 elements in the array, two 5s, 2 6s, and a 1. Now, the 5s and 6s, there are no elements with a greater frequency, so those are all going to be -1s. The only element with a greater frequency is the 1. And the greatest element to the right of that is going to be this 5. So we'll put a 5 here. Constraints, the array size can be between 1 and 10 to the 5th. 10 to the 5th, 100,000 elements in the array, same, between 1 and 100,000. Linear complexity and topic tags, hash, stack, data structures, yes. That's exactly what we need. The stack is kind of the key to it, as it was in the previous problem, but we need a hash map for this one to keep track of integer frequencies. So what are we going to do here? Array list. Okay, so we are going to create an array list. We'll call it result. It's going to be, let me get a pen here. It's going to be the same size as the input array, and it's going to be filled with -1s. So let's just put that here. It's 6 elements, all of which are -1. This is our initial array list. 1, 2, 3, 4, 5, 6. All right. Next, a map. Again, to keep track of the frequencies. You know, I can scoot. I guess I don't need to scoot it over so you can see everything there. The map. We're going to iterate through the array, put each element in the map, either add it to the map with a count of 1 or increment the count in the map. So what the map is going to look like for this array, we have an integer 1 that occurs 3 times. We have an integer 2 that occurs 2 times, and we have the integer 3 which occurs 1 time. Okay, then we get the stack, and then again we process this from right to left. Okay, so go through here. While the stack is not empty, actually the stack is empty. The stack is empty here, so we don't do that either. The only thing we do is push the array at element I. I actually should have something here that keeps track of I. I is going to start out as n minus 1, which in this case is 5. All right. So we are going to push array at I. What is array at I? It is 1. So we're going to push the 1. This will be our stack here. All right. Next time through, I goes to 4. And we're going to say while the stack is not empty, and the stack is now not empty, and map get stack peak. Okay, so stack peak is 1 in the map. That's going to be 3. Is it less than or equal to the frequency of, let's see, map get array or default I is 4. That is going to be a 2. Is 3 less than or equal to 2? No. Stack pop. The thing that's happening here is we don't want to put how do I want to say this? We don't want to put integers with a greater frequency on top of integers with a lower frequency. Because once we find an integer with a greater frequency, and we're moving right to left here, that integer with the lesser frequency is not going to be greater than anything. So we got to get it off the stack. It's not the case here. The stack is not empty. We are going to set I is 4. We're going to set the element at 4 to stack peak, which is 1. All right. So that is here. And we're going to set it to 1. And we are going to push array at 4. Array at 4 is 2. All right, push it. We are now down to I equals 3. I equals 3. Stack is not empty. Map get stack peak. Okay, so that is 2. And if we get it out of the map, the result is 2. Is that less than or equal to the frequency of array at I? What is array at I? Array at 3 is 3. And the frequency of it is 1. So this is not less than the frequency of 3. So we're not popping anything. If the stack is not empty, set result at 3 to stack peak, which is 2. Okay? Erase this. At 3, take that out and set it to 2. Okay? And then push array at I, array at 3, which is 3. Okay. Decrement I, we are at 2, so we are right here. Let's see, stack is not empty. Map get stack peak. All right, if we get the stack peak at 3, that is going to be 1. Is that less than or equal to the frequency of integer 1? It is. It is less. So we want to get it out of there because 3 is not going to be greater than anything. Well, actually, am I saying that right? The 3, the number at integer at index 3 is not going to be greater than anything. I'm sorry. Let me say it again. 3 is not going to be greater than anything. All right. We're still in the while loop. Stack is not empty. Get stack peak. Now we have 2. We're going to get a 2. Is that less than or equal to the occurrence array of I? Is it less than or it is? So we got to pop that. All right. That is gone. That 2 is not going to be greater than anything. And let's see. Yeah, actually you can see that from the array here that the 1 here is not, well, the 3 and the 2, the frequencies are not going to be greater than the 1. All right. And finally, is map get stack peak 1? Is it less than or equal to map get 1? Well, it's equal, so again, we have to pop it. Okay, gone. Stack is now empty, so we're out of the while loop. If the stack is not empty, well, the stack is empty. So we are just going to push array at I. Array at 2, that is a 1. And we'll push it. Okay? And we are going to move on to I equals 1. That is accurate, by the way, because when we were at array at 2, there is nothing to the right of that that's greater. So that needs to stay at -1. And actually the same thing is going to happen again here. But we are at 1 while the stack is not empty, which it is not. Map get stack peak. Well, stack peak is 1, and array at I is also 1. So those are going to be equal, and we are going to have to do the stack pop. Okay? Do the stack pop. And is stack not empty? No, the stack is empty. So we are just going to continue. This is going to stay at -1, and we will push array at I, push it to 1. Okay. We are now at the last element, index 0. Wow, the stack is not empty, which it is not. Map get stack peak. If we get that, it's a 3. Is it less than or equal to array at I, array at 0, 2. Is it less than or equal? Is 3 less than or equal to 2? No. So there is no stack pop. If the stack is not empty, set index 0, 2, stack peak, which is 1. All right. Red 0. I'm going to erase that. I probably should just erase the negative sign. That is now 1. All right. Does that match the answer? 1, -1, -1, 2, 1, -1. It does. Okay, so again, the key is just don't push greater frequencies on top of smaller frequencies. You got to pop them off of there, because once we find a greater frequency, that smaller frequency is not going to be greater than anything. All right. Next, is that it? Yes. Once we're done with that, return the result. Let's turn this off and run it and see what happens. Let me do a quick compile and run just as a sanity check. Okay, that worked. Submit. Okay. That's it. So a hash map and a stack, and we are done. Like the video, subscribe. You'll get problems of the day in your inbox every day. And see you next time.